Olivia, you want to go ahead?
Let me share my screen. Can you see my screen?
Yeah, I can see that.
Okay, so I made this kind of poster. Basically, I researched on the effect of microplastics on learning and memory in Drosophila and Melanogaster. So over 1.5 million metric tons of microplastics enter the oceans annually, with humans ingesting over 39,000 of those polystyrene microplastics, also known as PSMPs, raising concerns about the health implications of microplastics on humans. Although previous research has looked into the impact of the specific sizes of microplastics on learning and memory through other organisms like rats and mice, they haven't really looked into specific sizes that will specifically affect humans. So my study aimed to close that gap and see how learning and memory specifically affects humans. Drosophila melanogaster was chosen as my model organism due to its 60% similarity to the human nervous system and its ability to associate stimuli with behavioral responses. So flies were either exposed to 0 micrometers, 1 micrometer, or 5 micrometer PSMPs through their food, and they were ingested. They ingested it. So then I tested to see if their PSMPs affected them through an aversive phototoxic suppression assay. So Drosophila, to gain insight on how various sizes of polystyrene microplastics, PSMPs, affected those aversive olfactory learning in female wild type D. melanogaster, flies were subjected to light in a dark vial for 1 minute with negative reinforcement, which was the hydrochloride, and the light vial trial to train them to avoid their base instinct of moving towards the light. In the testing phase, flies were placed in 2 horizontally connected vials, one dark and one light, and after 30 seconds, the number of flies in each vial was recorded. So flies in the dark vial retained their memory of the negative stimulus associated with the lights, while flies in the light vial, if they failed, would succumb to their base instinct of moving towards the light. So you can kind of see it in that diagram that I made. It was you see the hydrochloride, and then 30 seconds later, you'd see if it failed, if the flies failed and moved towards the light, or if they exhibited learning and they moved towards the dark. So I conducted a Kruskal-Wallis test, and it's like a statistical analysis to see if the statistical significance of my results. 5 micrometers versus 1 micrometer, 5 micrometers versus control, and 1 micrometer versus the control. So my findings suggested that polystyrene microplastics, PSMPs, affects learning and memory, but not too significantly, because my hypothesis was that as the size of PSMPs increases, it impaired olfactory learning performance, and that it will increase due to the larger amount of reactive oxygen species, which leads to increased oxidative stress, which was tracked. So in the future, I would suggest, I was thinking that maybe this could extend to other not just polystyrene microplastics, other microplastics that can be found in oceans, because ocean acidification also happens, and polystyrene microplastics aren't the only microplastics that are found in the ocean. So yeah, and I would also like to thank Dr. Varkey and Professor Virgil for helping me with my topic, because initially I was going to choose to do, it was like this, it was like based on COVID-19 and analyzing specific trends in communities, and Dr. Varkey really helped me choose this topic and focus on this one, which I started during my school year.
Wonderful, Olivia. I really liked, you can stop sharing. I like this poster version as well. It's a bit different, but it's good that you came and you shared it. A very nice a one-pager. I think we can implement that. You can use that when you're going to show your counselor or teachers, because everything is in one place. So that's a good one. Yeah. Go ahead, Professor Varkey.
Great job, Olivia. I mean, this is like some real experiment that you have actually done. And I believe it's going to help you a lot. Also, I see that you have done quite a bit of research looking deep into what happens with the microplastic. So a question, do microplastics breach the blood-brain barrier?
Yeah, they do. They breach the blood-brain barrier, so that was also something that I had to look into. But yeah.
So do you know once it breaches blood-brain barrier, are there specific studies which show what it binds to or what it does to neurons?
Yeah, so what happens when it breaches the blood-brain brain barrier? It reaches the hippocampus. So yeah, and then that there's also neurological side effects too that was seen in the seen in the fruit flies.
Okay. Good job, Olivia. I hope like you'll be able to present this poster many different places showcasing your work.
Okay, thank you.